Good afternoon. Uh, Welcome to the first public lecture within the DA Iconic Week. So before we start, I'd like to give you an overview of the different events that we are conducting as part of the DA Iconic Week. For those of you who are not aware, as you know, we are currently, celebrating India at 75 or 75 years since independence, which is also known as Azadi Ka Amrit Mahotsav. This program of the government actually runs from March 2021 to August 2023. So within the celebrations that we have been conducted under the Azadi Ka Amrit Mahotsav, or AKAM as in short, we have had several events in the last almost 7 to 8 months. So what is DA Iconic Week is the following, that different departments of the government are actually allotted a certain week for celebrating and showcasing their achievements. And the Department of Atomic Energy has been allotted this week, 22 August to 28 August, to celebrate as Iconic Week. That is why this is the DA Iconic Week. And IMSC is a proud institution. It's an autonomous body of DAE, and we are proud to celebrate the DAE Iconic Week with several events. In addition to Azadi Ka Amrit Mahotsav, this also happens to be, by chance, many other things we are celebrating. Couple of things I want to mention. Most importantly, I would like to highlight that in January 2022, we completed 60 years of this institute. That's a proud moment. And as you have seen, we have been celebrating the IMSC 60, as we call it, with several events. We have the IMSC Distinguished Lecture, we have the IMSC Heritage Lectures, we have the IMSC Diamond Jubilee Distinguished Lectures and the colloquiums that we are conducting, and many other programs. So this is a proud moment for our institute. Some of you have seen the memorabilia that we have created for the IMSC 60 for this DA Iconic Week. So that's the second thing I would like to mention, that we are also celebrating. And many of our programs that we have conducted in the past 1 year, I would say, also fall in the spirit of what United Nations has been celebrating. That is the International Year of Basic Sciences for Sustainable Development. So we are trying to also adhere to the ethos of that as well. So with that, what we have planned within the DA Iconic Week is that you may be thinking what we did yesterday. So we actually did a school and a college outreach, or an interaction meet. We went to one school and one college, and today also we went to another college. We have basically informed them about what are the research activities in IMSC, what are the opportunities to students, college students and kids, and also invited them to be part of our public events this week. Following this is our first public lecture. I would like to mention that we have 5 public lectures planned within the DA Iconic Week. There are 3 heritage lectures. Today you will have the first one, aptly so, on Homi Bhabha, who has been a very important institutional founder for the nation. We have a second heritage lecture by Professor Shrirup Roy Chaudhary on Friday, which will talk about evolution of modern science in India. And finally, we have Professor Dani, who would speak about glimpses of India's mathematical heritage. We also have a special lecture which is being organized actually in cooperation with the Academy of Sciences, Chennai, which is on Thursday, which is very apt because this happens to be also the birth month of Professor Aladi Ramakrishnan, who was the founder of the institute. So in the honor of that, the Academy of Sciences, Chennai is conducting a Aladi Ramakrishnan Distinguished Lecture, which is given by our former faculty, Professor R. Parthasarathy. He will actually be talking about Aladi's life and his physics. So these are the 4 sort of heritage type of lectures we have. Also, we have tomorrow a distinguished lecture by Professor V. Kamakoti, the director of IIT Madras. Apart from that, we also have a program on Saturday, which is for high school students, and the program is titled Stimulating High School Students for a Future in Basic Sciences. That's already oversubscribed, and we have closed the registration. Lastly, I would like to mention that all the events that are happening, these public lectures essentially, they are streamed live on YouTube. If you are watching me on YouTube, you can actually ask questions through the comment section, and there is a moderator who is actually following your questions, and your questions may be taken up at the end of the lecture as well. Finally, I'm happy to note that this also is an important week for the city. My colleague Vishwanath, who actually co-organizes the AKAM events with me, he pointed out that this is the Madras week as well. So I think the DA Iconic Week is a small step towards contributing to the culturally vibrant and intellectually aware society of Chennai. With that, I will request Professor G. Bhaskaran our eminent physicist, our own, to chair the session and introduce the speaker. Over to
So
you.
it's a great pleasure to welcome my old friend Dr. G. Amarendra, who is a Raja Ramanna Fellow at Nuclear Fuel Complex in Hyderabad. So Amarendra is an experimental physicist who is well known for his work on positron annihilation, study of defects and damaged materials. It's a very important study, has been doing wonderful work in that field. And Amarendra was the director of Material Science Group and Metallurgy and Materials Group at IGCAR Kalpakkam. And also he headed the nodal center of DAE UGC consortium. In fact, some of the young people may not know, if you are doing experimental physics in this region of the country, and if you want to do some special experiment involving some special equipments, you can just walk in there. And Amarendra and colleagues used to help. So many papers have come and wonderful discoveries have been made. So that is the center he was heading. And he has got several awards. I don't want to read that. I don't want to come. I have known Amarendra for many years, and he's a very friendly and warm person, and wherever he has been there, things have been growing well. So it's a pleasure to welcome Amarendra to talk about.
He won the Homi Jehangir Bhabha medal in the DAE Institute.
Okay, yeah, thank you. So I will. So today he is giving the IMSc Heritage Lecture. He is going to talk about a legend who lives on, Homi Bhabha.
Friends, very good morning. I'm very happy and proud to be here on this occasion. I'd like to thank Professor Ravindran for extending this invitation, and Professor Rajit and Registrar Madam for all the nice arrangements they have made. And I just want to confess that I'm not new to math science. I have been in and out of math science for a very long time. But I was telling also Professor Rajit, please don't treat me like a guest. I'm more like an insider than outsider. So I'm very happy and proud to be here. And so what I attempt to do in today's talk, and I just also want to tell that the similar talk I have given at Hyderabad under the auspices of Indian Nuclear Society, meant for practicing engineers in ECIL, Nuclear Fuel Complex and Atomic Minerals Division. So what I have done in the current talk is I have removed most of the physics concepts or whatever. So the title of the talk, as you can see, is A Legend Lives On, the story of Homi Jehangir Bhabha. And of course this talk is given under the aegis of 75 years of independence that we have enjoyed. And the plan of the talk is the following. I would basically talk of his childhood and education. Quite often we see that whatever we are today and what we were when we were young, what were our parents, what are our friends, they have a very profound influence, and this is true for all of us, and it's true also for Bhabha. So it's important to know what was his childhood like. So that I would delve on. And this physics concepts I'll quickly run through just for the completion's sake. So I would basically divide Bhabha's life in three periods we can talk of. One is the Cambridge period, where he has done very fundamental work, which I will talk about and will discuss in detail. Second period is Bangalore period, and where it was more like a period when he switched from being a theoretician to more of experimentalist, equivalent you can say. Third period is where he has become an institution builder. That's when it's called Bombay period. So broadly we can look at three eras of Dr. Bhabha. And in fact it's very surprising this thing that Bhabha is for us is known only as a scientist, as an institution builder, but Bhabha is known to many more people whole of the world as a person who is very good at music, a person who is very good at artists, a person who loves nature. And in fact those are the aspects of him I came to know only while preparing the talk. I will also let you know as to what all he has done. So this is the broad outline of the talk. So let me just run through his childhood. So this is Bhabha's childhood photograph. This is Bhabha's parents. This is Homi Jehangir Bhabha. Bhabha has a brother called Jamshed Bhabha. Here is Jamshed Bhabha. And as you can see, he was born in Mumbai in October 1999 in a Parsi family. He comes from very educated family. His father was an Oxford educated lawyer, Mother Mehreen. If you notice, his grandfather was a distinguished educationist. He was the Inspector General of Education in Mysore State. So in some sense, he comes from a family which is highly educated. Point number two, while he was there at this thing, he grew up at Bombay, where entire his childhood was filled with Western classical music. This is very, very important. We will revisit this point. And he was into a lot of Western classical music, into books, into arts, into painting, into pencil sketching, and also more about Indian industry, iron and steel, because Bhabha's father has a kind of a relation with the Tata Steel Company. So Tatas were related to Homi Jehangir Bhabha. So they were also knowing a lot about steel industry and things like that. Of course, when he was growing up, he was also exposed a lot of discussions at home about freedom struggle, national uprising, and Mahatma Gandhi and so on. The concepts that India has to struggle to get its freedom and people have to work for the country was imbibed into him at the childhood. This is also important concept to remember. So, and Bhabha has received his early studies at Cathedral Institute at John Connon School at Bombay. So it's like he did his +2 or whatever we call now. So after his +2, he was to do his graduation, like you call this BSc honors or BTech honors, whatever you call. Towards doing this, he was sent to Cambridge. It's called Case College of Cambridge University. At the age of 18, he went to London all alone. And the reason why he was sent to London, basically because his father is into, as I said, in Tata's steel and process industry and things like that. And they basically wanted him to become a mechanical engineer. Why mechanical engineer? Because if you were to be a mechanical engineer, you know so much about the industry, how it functions, how the steel is made and things like that. So basically the purpose was he would acquire a degree in engineering, come back and take over, be some kind of a boss in the industry or whatever. That was the main purpose why he was sent to London. And things always go as we plan. And what has happened after he went to Bombay, after he went to London. So after he went to London at 18, he went to Cambridge. And as I said, he was basically enrolled in mechanical engineering. Within a year, Homi was writing passionate letters. What kind of letters he wrote? Just look at the letter that he wrote to Bhabha when he was just 18. He wrote a letter to Bhabha, his father. I am burning with a desire to do physics. I will and must do it sometime. It is my only ambition. I have no desire to be a successful man or head of a big firm. There are intelligent people who like that, and let them do it. It is no use saying to Beethoven, you must be a scientist, for it is a great thing. When he didn't even care two hoots for science. Basically what he meant was, you have to pursue what you are passionate about, not what your mind wants you to do, what world wants you, what your parents want you to do. So it is not in the nature of things. I therefore earnestly implore you to let me do physics. This is the letter that he wrote to father. Like, it's a very, very tough decision, and because he was sent for doing mechanical engineering, and his father was also strict, at the same time very liberal. So what did father do? So his father agreed to let him pursue theoretical physics, provided he gets his first class in mechanical engineering. That's been made a condition. So Bhabha, as we know him, he is a qualified mechanical engineer. Once he passed his mechanical engineering first class, his father also permitted him to do theoretical physics. I'll talk of what they are. So during the Cambridge period, 1927 to 1939, Bhabha spent 12 years. As you know, like what we call as BSc Physics or BSc Chemistry or BSc Mathematics, it's only 3 years course. When you do 4 years course, it's called honors. In Cambridge, it's called engineering tripos. Okay, it's normally 3 to 4 years in Cambridge. So Bhabha basically he went in 1927 and he did engineering tripos in 1930. So basically he's a qualified mechanical engineer. Soon after finishing his mechanical engineering, he did mathematical tripos in physics. So you can see, since he did this already, he could finish this course instead of 4 or 3 years, he could finish it 2 years. Then Bhabha enrolled in a PhD in cosmic ray physics. He completed his PhD in 1935. Essentially, Bhabha got his doctorate when he was 26 years. So you can see he's at such a young age become doctorate or PhD holder, that too from Cambridge. So incidentally, for those of you who don't know what's Cambridge, just for information, Cambridge and Oxford universities are located in and around London, are in the forefront of research in atomic physics. The so-called Cavendish laboratory, from where the maximum number of Nobel laureates have come from, Cambridge University is a part of Cambridge. Cavendish laboratory is part of Cambridge University, where Bhabha did his PhD. So, and important point to note is, ultimately, as we talked of his childhood, this is also true. The environment molds what we are. It's based on where we live in, who are our friends, who are we go with. We get molded and we get typecast based on their likes, dislikes, and things like that. So, what was the environment like Bhabha at Cambridge? That we will see. Before I run into his scientific work, I just want to run through what are the physics that Bhabha dealt with very, very briefly, not going into depth, but I made these slides meant for the other audience. I just want to run through. We are all familiar with the nitrogen 714 atom, where you basically have got 7 protons, 7 neutrons. And the person who proposed this atomic model is Niels Bohr, who himself is Nobel Prize awardee. And this atomic model proposed by Bohr was subsequently modified by Rutherford. This is the atomic model of nitrogen 17. We will deal with Bohr as we go along. We will deal with nitrogen as we go along. So what are these protons and neutrons? And if you notice, we are in the era of 1930. So essentially in 1930, all we know was protons and neutrons. If they were to so strongly bound in the nucleus, there is a very strong force. And how do they can get bound like this? So no one knew what it was. And there was a physicist called Yukawa who proposed that the proton would become neutron and neutron will become proton by exchange of unknown particle. He said unknown particle. Subsequently we came to know it's pion, much later, maybe 20-30 years later. So the so-called pi meson is the one which exchanges between proton and neutron. That's what I put here, is called U standing for unknown particle. I will show some of the Bhabha's paper where he refers to this unknown particle, U particle. Okay. So this name pi meson or mu meson has stuck later. Just to give you information too, there are two kinds of mesons called pi meson and mu meson. Mu meson is lightweight while pi meson is heavyweight. Originally people thought it's the mu meson which is doing this. Subsequently pi meson is not with this. And as I said, in 1930s neither positron was known nor pi meson was not. So this is the era when Bhabha was doing his honors in physics. So this is important because all this has connotation to what Bhabha did. So let me just run through what is a positron. So as you can see, here is P.M. Dirac, and the history of positron antimatter began in 1928 when Paul Dirac made a relativistic equation which when solved gave a negative energy state, which we are all familiar. Hence he proposed a positron, and this positron was discovered by C.D. Anderson in 1932. And as you can see, Dirac, who proposed this positron in 1928, got a Nobel Prize at 1933 at the age of 31 years. And Anderson, who discovered this positron in 1932, got Nobel Prize in 1936. And just for the information, this is called a image plate track of a positron, and as the cloud chamber it goes through, you apply a magnetic field, this particle gets bent. This is the very first image of positron seen by Anderson, and this is physical principle. Why are we talking of Dirac? Because Dirac happens to be the guide for Homi Jehangir Bhabha when he did his mathematical tripos. So Dirac was Bhabha's supervisor for mathematical tripos in 1932. That's when he just got his Nobel Prize. So that is the kind of influence Dirac had on Bhabha. So Dirac, remember, Bhabha was just 19. He was just 21 years old boy, and when his own boss got a Nobel Prize. So subsequent to his mathematical tripos, Bhabha has done his PhD with a professor called R.H. Fowler. Fowler was a Bhabha's PhD supervisor. Fowler happens to be also supervisor for Dirac. So Dirac's guide and Bhabha's guide is the same person called Fowler. He is a very great mathematical physicist, and many people have got a Nobel laureate, have got Nobel award under him, and many people have become FRS working under him. So one aspect which I want to talk about is positron, because positrons and mu meson is entire physics fundamental work done by Bhabha. This is just all that we know. So if you have got particle antiparticle, when they annihilate together, you get two gamma rays in opposite direction to conserve momentum and energy, which we all know. And the converse is also true. If you were to destroy energy, the energy so destroyed becomes a mass. Example, when you destroy gamma ray or convert a gamma ray through pair production, you can create a particle antiparticle pair, which we are familiar. And third concept I would like to use is when you got a very high energetic charged particle is bent due to some reason, it emits electromagnetic radiation. This is known as Bremsstrahlung radiation. So 3 concepts we make use of. One is about particle-antiparticle annihilation. 2 about creation of pair production. 3rd is about Bremsstrahlung radiation. Let's understand Bhabha's work. So before I go to that, let me tell what are the cosmic rays. The word cosmic rays has a connotation into this thing. Nobody knew what were cosmic rays. Originally it was thought, since they were seeing radiation on the earth, they all felt the earth is emitting radiation. This is what everybody else thought. And there were smart physicists and things like that. A person called Victor Hess in 1910, all he had was an electrometer. So what he did was, he took this electrometer on the earth, went up in a balloon by about half a kilometer, measured, went out by another 1 kilometer, measured. He showed the so-called the charges or radioactivity that he measures increases as it goes up in the sky, which proved it has nothing to do with the earth. The so-called the rays or radiation is coming from outside the earth. It is coming from outside. We don't even know where it is. Since the origin is not known, it's called cosmic. So how do we define cosmic? Incidentally, and beyond that, what was known was most of these primary particles were found to be, as I have written here, are protons and helium particles, a little bit part of carbon and iron. Where are they coming from? These are very high energy particles. They range from MeV to 10 raised to 16 eV, huge. Even today we don't even know the origin, where are they coming from. So as you can see, as we are sitting, we are being bombarded with this radiation all the time, whether you like it or do not like. So these particles are coming and going through, and so the primary particles are the hydrogen or proton, helium. But once they come and hit the atmosphere, I will define what you mean by atmosphere. Once they come and hit atmosphere, the primary particles give rise to secondary particles. These are called secondary cosmic rays. So most of the Bhabha's work has to do with cosmic ray showers, which I will talk of. And recently, or about maybe 10 years ago, the kind of energies that we deal on Earth, like where we talk of Geneva, where super cyclotrons or super accelerators, at best you can get 10 raised to 12, 10 raised to 14 EV. Beyond that, we don't even get energy. It's not impossible for us to achieve. However, recently in 1991 or 92, they have discovered 10 raised to 20 EV particle. It's called, incidentally, it's called oh my God particle. Because this kind of energy we can never achieve on the earth. And where it is coming from, nobody knows. It's still a mystery. And how we got such high energies, what gives rise to such kind of gamma ray is a big question. So let's run through the atmosphere. So what do you mean by atmosphere? We are familiar with all the various spheres that we have in the atmosphere. And all I want to say is, when the cosmic ray particles enter Earth's atmosphere, they collide with molecules, mostly nitrogen, because nitrogen is made in the atmosphere of almost 78%, right? Oxygen and so on. So as you can see, this is called troposphere. The troposphere stretches until 10 kilometers. Most of the so-called atmosphere is restricted to 10 kilometers. That is, if you were to weigh the total mass of entire atmosphere, the entire weight comes within 80%. Means most of the gases are there within 10 kilometers. And most of us know, when you fly by aeroplane, we fly at 33,000 feet, right? 36,000 feet. If you convert 30,000 feet, approximately, it comes to about 10 kilometers. And why 10 kilometers? When you cross 10 kilometers, the amount of air or whatever is so less, there's hardly any friction for this thing to move. So you basically conserve the fuel. So that's why we fly at 36,000. If you fly too high, there's not enough push for the plane. So for all practical purpose, we can define atmosphere to be somewhere between 30 kilometers to 10 kilometers. Beyond that, there's nothing. So what do you mean by cosmic rays? Let's go back to cosmic rays. We know maximum is nitrogen. What does nitrogen do to cosmic rays? Once cosmic ray showers comprising of 2 components. First part is heavier particles called protons and neutrons. They are found near the atmosphere. Since protons and neutrons have such high mass, they can penetrate all these 10 kilometers, they can reach Earth, no issue. However, you do find particles such as electrons and positrons. They are so lightweight, and when they pass through this 30 to 10 kilometers of heavy atmosphere, you should all get shielded. You should not observe any of these particles on Earth's surface. However, you do observe. That is a mystery, and it was very difficult to explain how you are getting, and that's what Bhabha worked on. And incidentally, this height called 100 kilometers is called Karman line, and Karman line is recently in the picture. because if you cross this Karman line of 100 kilometers, if you stay for 1 minute, you become cosmonaut or you become astronaut. So all to get qualified to be a space tourism, you cross in anything that you can get, cross this 100 kilometers and stay for 1 minute, you become astronaut. Okay, so how do we explain that you are seeing electrons and positrons? Electrons, positrons in these particles. And here is back to our neutron, our nitrogen particle, nitrogen 14. When the gamma ray comes and strikes, there is no ionization. However, when a charged particle comes and hits nitrogen, you find these things. And I have shown here a cloud chamber. And remember we talked of the cloud chamber, how the positron was found. And here is the air shower. You can see the first, second, third, fourth. These are all lead plates. So how do you determine a particle when it's coming? So what you do is put one lead shield, second lead shield, third shield. It's all closed chamber. And as the energy is increased, it goes further down. When the energy is too low, it will get stopped here. And as it's going through, the shower width increases. You can see in this cosmic ray shower, the shower width is increasing. So what did Bhabha do? Again, we are back to the same question. We talked of all this primary and secondary. So this is called the hard component of cosmic rays, which is protons and neutrons. At that time, pi mesons were not known, but this is how it is. So how do you get electrons and positrons? That's a question which was puzzling for a very, very long time, and no one had an answer for it. So what did Bhabha do? Remember our physics concepts that we talked of. So all that happens is the gamma ray gives rise to pair production. You get electron and positron. Electron, as it is slowing down due to Brimstone, gives rise to gamma ray. Gamma ray gives rise to pair production, and electrons, while slowing down, gives rise to gamma ray, and so on and so on and so on. So what should have stopped here gives rise to a shower due to the concepts of pair production, Brimstone, and so on. And what should have stopped here gives rise to secondary emission. It's like a big shower. It's like how you take water shower. So you end up having so many electrons and positrons at the sea level. What should have stopped within 2 kilometers? You can notice at the sea level. This is called electromagnetic shower. This hard component was explained by people, but the soft component was never explained. Anybody, and people didn't even understand. This explanation of this electromagnetic shower of electron and positrons at the sea level and the calculation of the number density, fluctuations, angular divergence is called Bhabha-Hitler theory. We also heard Hitler. So this is Bhabha-Hitler theory. This is Bhabha's original paper published in 1936. We are looking at 86-year-old abstract, right? So we are celebrating 75 years of freedom. This 86 years old abstract by Bhabha. This was published in Proceedings of Royal Society, and Bhabha co-authoring with Hitler. So this is all about, he explains how this should be done and things like that. The next work that Bhabha had done, this is much more significant. In fact, we all know that we only know Raman scattering, we only know Bose-Einstein statistics, and our names getting stuck to any process or any this thing is very, very rare. And unless you have done very significant work, it doesn't happen. It so happened, we all are familiar with something called molar scattering, where you can't distinguish electrons one from the other because they're undistinguishable particles. The scattering of electrons is called molar scattering, and basically we involve exchange effects when you talk of, because they're indistinguishable. However, we know that positron is a positive particle compared to electrons. Can one distinguish positron? Everybody thought you can distinguish. It's Bhabha who proposed, if you invoke positron to be an electron in negative energy state, in principle positron and electrons are indistinguishable. And he invoked electron-positron scattering, and the so-called electron-positron scattering incorporating exchange term is called Bhabha scattering. And here is Bhabha's original paper in 1935, the scattering of positrons by electrons with exchange and Dirac series of positron, right? And then here is abstract where he quotes, the effect of exchange in general relativistic case will still be considerable if one of the two electrons be initially in a state of negative energy. He is referring to positron, right? And once this paper was published, subsequently within 2-3 years, people name without Bhabha's this thing. They talk of electron-positron scattering as Bhabha scattering. It got stuck. Even before he came back from Cambridge to India, his work was so phenomenal and so well known. This I would consider is the most important work of Bhabha in my personal thesis. What is the work that he did? Remember, we talked of electron-positron showers. Let's look at muons. These muons, as you know, are unstable particles. They have a lifetime of 2 × -6, that's about 2 microseconds. And remember, they are all coming from somewhere in stars, interstellar or sun or whatever. So 2 microseconds, if they enter into atmosphere, how long they will live before they decay, right? Because they have a half-life of 2 into minus 6 seconds. So if you look at it, 2 into minus 6 seconds is their short lifetime. So if they enter into atmosphere, how long they live? So can they come to 10 kilometers down to Earth's atmosphere? Answer is no, they cannot come in because they should die before. Because if you multiply their time by velocity with which they are traveling, which is almost speed of light, you would get 0.6 kilometers, which means within that 2 into minus 6 seconds, they can only travel 0.6 kilometers. All of them, they should stop here. They should never reach 10 kilometers, right? Only concept that is known is they are traveling at the velocity of light, almost. So how do you explain the muons reaching the Earth's atmosphere? This is most original work done by Bhabha. And here is Bhabha's paper in 1938. This paper I read 3 times. I couldn't get the clue as to where it was said. Only third time when I read, second time when I read, I got this clue. We have generalized a theory put forward by Yukawa, where Yukawa's reference is here. This is 1935. And existence of new particle of mass about 200 times as that of electron. He goes on. Now he talks here. Look at this paragraph that Bhabha wrote. A positive U particle, unknown particle, that's so-called proposed by Yukawa. The positive U particle at rest may disintegrate spontaneously into a positive electron and a neutrino. This disintegration process being spontaneous, the U particle may be described as a clock. Hence it follows merely from the consideration of relativity, the time of disintegration is longer when the particle is in motion. So he is basically invoking relativity to say, since the particle is in motion, the lifetime of the particle will get enhanced. So how do we understand? This is in fact a very nice depiction that I saw a cartoon. So we are sitting on the earth, and here is the, let's say, muon which is coming from the top, and this is a distance of 10 kilometers. When you see from Earth's surface, the muon lifetime, as you see it, would appear as if 5 into minus 5 seconds. It's not 2 into minus 6 seconds, the time gets dilated. Whereas when you sit on the muon and coming down, this 10 kilometers length that you have or depth that you have becomes only 450 meters. This is called time dilatation, which happens. So how do we understand time dilatation? The simplest example that you can see in the literature for time dilatation is twin pair rocks, where you got 2 twins, you have a twins, 2 sisters. One sister is on the earth, second sister take let's say a rocket or a space flight or whatever. She goes comparable to speed of the light around the earth, and let's presume both the clocks are matched. When this sister who's on the flight comes back to the earth, you will find this clock is moved faster while this clock has not moved at all. It became very, very slow. Hence the sister who's on space flight is much younger or did not age much compared to the sister who's on the earth. This is the explanation that you can invoke, and this time dilatation, as it was told, was very first time Bhabha proposed for these things. Third thing which Bhabha was known, he was also known very this thing. Until Bhabha's time, people were using the word called, like, since you got electron, positron, meson is being called as a mesotron. Here is this thing, the fundamental length introduced by the theory of the mesotron, he defined, he called it a meson. So then he wrote here, it would therefore be more logical and also shorter to call the new particle as a meson instead of mesotron. Since that time, the word mesotron is being called as a meson, and Bhabha is credited with naming this particle as meson, and it is not known much in the literature. So let me summarize this. Of course, he has done much more work, but these are the more fundamental works that Bhabha has done. So let's summarize. So Bhabha was at Cambridge, did his mechanical engineering, did his mathematical tripos, and then he did his PhD with Fowler. And instead his PhD thesis topic was on the cosmic radiation and the creation and annihilation of positrons and electrons in 1935. And Fowler was such a great physicist, guy. PM Dirac, NF Mott, Chandrasekhar, all of them have done their PhD with Fowler. All 3 of them are good friends. Okay, so I just given the same titles that I have explained to you as Bhabha's most fundamental work, and I have taken all this data from these 3 references. Here is Dirac, and in fact Bhabha worshipped Dirac like his kind of mentor or whatever. And in fact Dirac came to TFR, and this is a photo of Bhabha with him. So all I want to say is that when you choose a guide, a teacher, a mentor, it is like lifelong lasting impressions. Just as our parents leave a lasting impression on all of us about our own personality, This is true with whom you work with. You acquire all his good qualities, you acquire all his skills, all his things that lasts for a lifetime. So here is just a picture of Bhabha in somewhere in Princeton. This Einstein. This is Yukawa. Remember we talked of Yukawa. This is a famous scientist called John Wheeler. John Wheeler is very famous because apart from working on Manhattan Project, he also worked on a concept called wormholes, where basically wormholes are something you enter in, you end up somewhere else in space. Only thing is when you enter in somewhere else in space, the time may be 20 years ahead or 20 years back. This is supposed to be very, very maverick physicist, and this was Bhabha with them. And as I said, your environment plays a huge influence. His professors, mentors at Cambridge and Europe include Lord Rutherford, Fowler, Dirac his guide, Pauli, Bohr and so on. And his colleagues, means with these people he worked when he was in Cambridge, his colleagues and peers were Chadwick, who discovered neutron, Cockcroft, accelerator, Blackett, Wilson, Enrico Fermi and so on. So essentially Bhabha comes from a background where he rubbed the shoulders with Nobel laureates. That was his background when he was doing his work at Cambridge. So he basically comes from very highly academically rich environment when he came to India. So why he had to come back to India? So he spent 27 to 39, 12 years at Cambridge, and 39 he came to India for a short vacation. He didn't want to stay here forever. He just came for a vacation. In 1939 when he came, World War II broke, and his returning to England was difficult. And those of you who don't know what Second World War, it started in 1939, it went on till 44 to 44 end. So during those 6 periods, whole world is frozen. There is no communications, no exchange, nothing, and people can't even move. So during the 6 years, Bhabha got stuck in India. He couldn't go back. So what did he do? So this is the end of his Cambridge period, and we'll see what he did at Bangalore. So here is IISc. As you know, IISc is funded by Tata's. It's called Tata Institute of Fundamental. Tata Institute of this thing. Before it became Indian Institute of Sciences, it's called Tata Institute in Bangalore. Okay. So he joined Indian Institute of Sciences in 1939. So remember, he came back in 1939, right? 1939. So 1939, he was already PhD from Cambridge. He joined as a reader, where C.V. Raman was head of the department. Okay. He joined in 1939. Within 2 years, he became a professor in 1942. When he became professor, he was just 32 years. How they promoted him so fast, you might ask. And Bhabha was given Fellow of Royal Society in 1941. There were hardly 4 or 5 Fellow of Royal Societies in India, that is British India at that time. A very handful of people, including C.V. Raman, maybe Bose and so on. So Bhabha happened to be at 32, he became FRS. Obviously, he became a professor of physics at IISc. So as I said, his transformation to theoretical physicist to experimental physicist started at IISc. He set up a cosmic ray research unit at IISc with funds from Tata Trust. Somehow while spending time at IISc, over a period of 6 years he was there at IISc, this is where his exposure to a childhood that there is a freedom struggle, you should work for the country, has made a huge influence on him, and we'll talk about what influence it had on him. So that's when he wrote a letter to Tata Trust in 1944. What was the letter he wrote? Incidentally, before I come to the letter, here is Bhabha. So how do you instantly be talked of that Hess, how the cosmic ray? So what you do is you put a balloon, you know, all the airborne balloons. You put a balloon, into that you put all your radiation measuring devices. You send it up in air. As it goes up at different heights, you can measure the radiation, and you can get to know what kind of, from that based on you can identify the particle. And this is what experimentalists do. And here is Bhabha doing such experiments. This is Bhabha sending a cosmic ray payload in this thing. And he was using British aeroplanes to drop this payload from different heights and measuring this cosmic ray measurements and things like that. Cloud chamber experiments at scattering and mesons, Strelje. So Bhabha was basically getting converted into experimentalist, being a hardcore theoretician. In fact, Bhabha's eminence was so eminent and so large. Raman, he was introducing Bhabha in Indian Academy of Sciences meeting at Nagpur in 1941, and look at the way Raman introduced Bhabha to the audience. Before a speaker comes in, we introduce, like how we did now. That's how Raman introduced. Look at how he introduced. Raman introduced him Bhabha is a great lover of music. He's not a scientist first. He's a great lover of music, a gifted artist, a brilliant engineer, and an outstanding scientist. So you look at the order of things, how it came. He ended with a brilliant scientist, and then he came up. Then he paraphrases by saying, he is a modern equivalent of Leonardo da Vinci. I mean, Leonardo da Vinci is like his kind of achiever, and there's nothing that he did not do. He was comparing Bhabha to Leonardo da Vinci. That's kind of image Bhabha had, not only within India, but even outside in the world and things like that. So this is the very famous letter of Bhabha that he wrote to Sir Sohrabji Trust in March 12, 1944. But for the letter, all of us won't be here and talking about this talk or whatever. So look at what he wrote in that letter. He wrote, I had the idea after World War I, II, to accept a job in good university in Europe or America, because universities like Cambridge or Princeton provide an atmosphere which Indian university provides at the moment. Then you see what he says. However, it is one's own duty to stay in one's own country and build up schools comparable with those that other countries are fortunate in possessing. The scheme now I am submitting to you is an embryo from which I hope to build up in the course of time school. And in the same letter he continues and says, see what he says. Moreover, when nuclear energy has been successfully applied for power production in a couple of decades from now, India, remember we are not even independent. This is 1944, we got independence only in 47. In 1944 he writes, moreover, when nuclear energy is successfully applied for power production in a couple of decades from now, India will not have to look abroad for its experts, but will find them ready at hand. I mean, it's kind of incredible prophecy, and he knew what is going to come on, and he could say things which is very, very difficult to say things, because can you talk of nuclear reactors in 1944? I will tell you it's impossible. Why? Instead, this is a letter, original letter of Bhabha I downloaded from DA archives 1944. You can see this Professor Bhabha FRS, my dear Sir Saurabh. So can you talk of nuclear power production in 1944? Look at the reality at that point of time. In March 1944, nothing was known about nuclear power reactors. The first controllable chain reaction in a laboratory, so-called Chicago piles, at University of Chicago was done in December 2nd, 1942 by Enrico Fermi. About a year before, that if you take December 42 be 43, just 1 year before only they have done a controllable nuclear experiment. No nuclear reactor was built yet. All that was known is 2 years later we have exploded on Hiroshima and Nagasaki nuclear devices by US. So in 1944 that nuclear fission can be used for power production was unknown. Here is a man who is predicting it can happen, and India will not have to look forward to abroad, but they will find experts. It's like a real prophecy. So what happened as consequence? Incidentally, Tatas are very liberal in funding. They not only funded Bhabha, so-called the Saha Institute of Nuclear Physics, where there is small cyclotron. Even before independence, the Saha were funded by Tatas, and the same for Tata Institute in the IISc, same for Tata Memorial. So what did Bhabha do? So this so-called Tata Institute of Fundamental Research was founded in a small room in IISc Bangalore in June 44 or so, in June 45. By December 1945, even before we got independence, this is one house in Kenilworth in Peddars Road in Bombay, and this is a house where Bhabha was born. In this very house, he started Tata Institute of Fundamental Research in 1945. Until 48, this Tata Institute of Fundamental Research was running in this house. He basically rented a premises from his own aunt and was running his laboratory there. In 1948, he moved to a new building called Old Achet Club, which continues to be, those of you who gone to Bombay, next to Gateway of India, there's a huge building called OIC. That's where Department of Energy headquarters is located. So he moved it in 1948. So what was the funding that he looked at? Look at the funding. This is like our monthly salary or whatever now. TFR was set up in 1945 at Bombay with a funding of 45,000 rupees per year from Tata Trust, and the balance from Government of Bombay of 25,000 rupees. And Government of India, remember, we don't know what is Government of India in 1944, right? I mean, there's nothing like Indian government, it's just Government of India. 10,000, all put together with 80,000 rupees, Tata Institute of Fundamental Research was started. It must be huge money at that point of time. So as the story cut short, so it went on till 45 to 48 here, and 48 it moved here. As you know, we got independence in August 15, 1947, and Pandit Nehru had become first Prime Minister, and AEC, the Atomic Energy Commission, was formed in 1948 with Bhabha as its chairman. What next? And this is 2nd August 1954, a separate department called Government of India, to be called as Department of Atomic Energy, shall be created with effect from 3rd August 1954. This formation of DAE on August 3rd, 1954 was formed. So DAE formation day is August 3rd, and Department of Atomic Energy shall be allocated to the charge of Prime Minister. I mean, the chairman of Atomic Energy Commission reports directly to the Prime Minister. And one more thing is, if you notice, almost all the departments in entire central government, if you look at, they have ministers, they have secretaries or whatever. All of them are located in Delhi, none of them beyond Delhi, and almost all the department secretaries are IAS or IPS or whatever. Basically, they come from IAS cadre as a secretary. The exception usually for space and atomic energy. The chairman AEC is also Secretary Department of Atomic Energy. All other government departments have headquarters in New Delhi. DAE alone has its headquarters in Bombay. Same is space, its headquarters in Bangalore. And so DAE and DOS are directly under Prime Minister. So this is the origin of Bhabha. This is the origin of so-called DAE in Bhabha's time. What next? So research in nuclear physics began in TFR in the early 50s. This Cockcraft Walton accelerator bought from UK. Here is Bhabha before the accelerator, cascade generator. So basically, since he was into particle physics, he basically wanted an accelerator so that he can do a lot of transportation experiments and detect the particles and things like that. So a lot of experiments were being done. The credit to Bhabha, remember we got independence in 47. In 1950, that is 3 years from independence, he has conducted an international conference on elementary particles. Right. Who's who in the world came to TFR in 1950. Of course, in TFR building was not there in 1950. They came to the other building that I showed as a OIC. This was Tata Institute of Fundamental Research. Bombay building was founded in 1954. Here is the foundation ceremony of Tata Institute of Fundamental Research. You can see Pandit Nehru. Here is Morarji Desai. This is JRD Tata. This is Saklatwala. This is Bhabha speaking there. This was founded in 1954, while TFR building was inaugurated back by Nehru in 1962, and this is TFR building. So what was and incidentally, the entire structure for TFR, the architects have been drawn by French designer and things like that, because he wanted to be completely different design and things like that. So initial research was carried out on areas of cosmic rays, high energy physics, theoretical physics, and mathematics. Later, the institute expanded in research to various other areas. Incidentally, TFR also had a pioneering work that led to designing of India's first digital computer. It was made at TFR. And most of us, we sweat, like while we do research, when we are asked to do something else and we say we are busy with research or busy with my work or whatever. Look at what all Bhabha was doing. Bhabha was director of TFR. Bhabha was director of AEET, that is BRC. He was setting up research reactors. He was running the management. He was doing the recruitment. And he was running up the administration. He was designing buildings, and all the gardens that you see in BRC have been designed by Bhabha. He was excellent painter. I'll show you some paintings. He was practicing music, and he was into research. So Bhabha is one man all-rounder. Because he was doing something, he did not leave anything else. Everything he was running parallel machine. And I will show you examples of both his scientific work and his artistic traits. So just want to tell you as to what are reactors. So we know independence is 47, AEC is formed in 48, DAE is formed in 54. A reactor called Apsara was commissioned in BRC in August 4th, 1956. Look at the year. Within 2 years of DAE formation, he made a new reactor. And a reactor called Cyrus, Canadian Indian reactor, was made again by Bhabha in 1960, within 4 years of the first reactor. And a reactor called Zerlina, zero power reactor, was commissioned in 1961. Look at the pace at which he is building up reactors one after the other. All the research reactors so that we get trained into welding, and there are many more reactors. So here is the Apsara reactor, is a water floating reactor which was commissioned on August 4th, 1956. And here is Pandit Nehru with Bhabha. And in fact, you can see that he is wearing a helmet to visiting the Apsara reactor. Soon after commissioning, he came here. You can see this is the board which was said, Atomic Energy Establishment, Trombay, Apsara. The first reactor in Asia reached criticality on August 4th, 1956, formally inaugurated by the Prime Minister Jawaharlal Nehru. On Sunday, January 20th, 1957, Director H.J. Bhabha, the project engineers are A.S. Rao and Prasad. Right? This is first time in entire Asia that a nuclear reactor has been commissioned. So look at how people react, and we all know who's R.K. Lakshman. So soon after this reactor was commissioned in August 56, this cartoon was made by R.K. Lakshman in 1957. Here is Pandit Nehru pulling a common man on a bullock cart driven by a nuclear wheel, because he has removed the normal wheels of the bullock cart and he has fitted with atomic power station. Where is this thing? So basically the thing that is being exposed is, here is Nehru who's trying to fast pace the entire development in the country through science. That's the message that is being given by R.K. Lakshman. And Apsara Foundation given rise to training of a lot of scientists and engineers in the reactor technology. Don't think that Bhabha had a very smooth ride, and all of us have difficulties in life and we cry or whatever, but you should not give up what you are pursuing. This is very, very important. This is true for Bhabha too. He had a lot of problems in setting up things and doing. And one example is, while commissioning Apsara, he found that the people were waiting they were working around the clock and they had no food because canteen used to close down. And how do you get food and how do you transport people? So he asked his administration, get me 2 cars to transport people and give me food for the best hotel for all the scientists and engineers. And obviously administration has to go by rules. They said, no, this is not permitted. Then he said, tell me how it's permitted. Then they said, you should get permission from your boss. His only boss is Pandit Nehru. Look at the letter that he wrote. 2 cars should be put at their disposal on 24-hour basis, which will take them from their residence to place of work in Trombay and back. That lunch and dinner supplied by an appropriate restaurant should be provided for them at Trombay in the reactor building. Both A and B are not permitted by government regulations, and I therefore wish to have Prime Minister's approval for the action taken. Incidentally, this provides an ample example the way in which present rules and regulations of the government are not really suited for executive work which is to be done at speed and pressure. Imagine writing a letter to Prime Minister, right? He wrote that letter. You wouldn't believe it. This letter, the note seems to have been rushed to Delhi and Nehru approved on the same day with the words, I agree. So imagine even to get the cars or to get the food done, he has to get, because he was reporting officer, whatever you call. So basically what I want to show is, shows what kind of struggles you have to go through to setting up things and running the things. And you have to stand by all your colleagues at all the time. That's a clear indication of a great true leader, right? Because you have to be with your colleagues and support them all times, and Bhabha never hesitated to do it. Incidentally, the so-called AEET, I've been saying AEET stands for Atomic Energy Establishment Trombay. This is the name given by Pandit Nehru on January 20th, 1957. This AEET was later renamed as Bhabha Atomic Research Center in 1966. I will tell you why it was renamed later. Here is a reactor called Cyrus, right? The Cyrus is the second reactor made by Bhabha, and in fact, obviously Pandit Nehru also came to visit the Cyrus reactor. And while building this reactor, this was built with a Canadian collaboration. We were getting lots of things from Canada, but Bhabha felt, now that we have built Apsara, we are building the second reactor, we should be self-sufficient, we should be able to do things. So he felt the entire fuel rods, some fuel rods, that is uranium fuel based rods, should be made in India. Imagine getting uranium in-house from the mines, processing it, making it into rods, putting it into the reactor. It's such a involved process. And look at the way he wrote. Dr. Bhabha decided that unlike Apsara, Cyrus should have Indian-made fuel elements. In 1959, he informed Pandit Nehru, I have little doubt that we will be able to make satisfactory fuel elements. There are hardly 5 countries in the world which make their own fuel elements today. You won't believe it. He made the fuel rods, and Canadians didn't believe it. He sent one of the fuel rods to Canada to test. Canadians tested. It seems the fuel made by Indians had performed far better than Canada, and Canada had agreed, go ahead, fill your own fuel. And in fact, half the fuel for the reactor was made within India. And here is Professor Brahma Prakash, very eminent metallurgist, who helped Bhabha in many ways to do with metallurgy, material science and things like that. and here is Bhabha at the control of the Cyrus reactor, and this is the Cyrus reactor that you see. This is 1960, and here is, remember in those days there is nothing like WhatsApp, or you don't get email or whatever. So how do you send congratulatory message? There used to be telegram, and here is a telegram from Nehru to Bhabha. Prime Ministers, hearty congratulations to you and all your colleagues on successful operation of Canadian reactor, Jawaharlal Nehru, Canada-India reactor, Jawaharlal Nehru. Right? I mean, imagine getting such congratulatory message from the Prime Minister. I mean, what kind of kick it is. And in fact, as you see, whenever he has done, he has given the credit to his younger colleagues, Bhabha. And here is Lal Bahadur Shastri visiting after Nehru's death. He became the Prime Minister. He was visiting BARC. I also want to tell you this. Bhabha's eminence, the work that he did at Cambridge and the work he did of Apsara, Cyrus commissioning was so large. I am sure that all of you know there's something called IAEA, standing for International Atomic Energy Agency, IAEA. We all think that is formed later and all, but we'll see how. So even before IAEA formed, the UN Commission decided that since atomic energy is becoming popular, we should have a focused meeting of all countries together. So this IAEA has appointed a special committee of Brazil, Canada, France, India, USSR, UK and USA to conduct a meeting. This was given by Secretary General, and the chairman for this meeting, all have opted unanimously Bhabha to be president. Right? I mean, despite being Indian, despite not comparable to US and USSR in terms of atomic energy, all felt that Bhabha's fundamental work is so important. They have chosen Bhabha to be the president of this president of this United sponsored meeting. First meeting was conducted in 1955, second meeting was conducted in 58, third meeting was 64. Bhabha was elected as president of first UN sponsored meeting on atomic energy in 1955. Brahma Prakash, whom I have shown, assisted him in scientific organization of the meeting. IAEA did not exist then. How do we know that? And incidentally, remember our Bohr, and here is Bohr, Niels Bohr, who presented a paper with Bhabha in that meeting of this peaceful. The title of the paper is Peaceful Use of Atomic Energy, and the authors are Homi Jehangir Bhabha and Niels Bohr. In fact, this very paper that Bhabha had written with Niels Bohr, and he talks of first epoch, of second epoch, third epoch, he talks of nuclear era and things like that, and how the nuclear energy can change the world. Bhabha talked about it. Remember, here is a quotation by IAEA Director General Mohammed El-Bardi, Vienna, September 29, 2019. He was the IAEA Director General. See what he says. He, means Bhabha, was the chair of the first international conference on peaceful use of atomic energy held in Geneva 1955. That led to the foundation for the launch of IAEA 2 years later. So in some sense, it's Bhabha who was kind of one of the founder members of IAEA. Legend has it, Dr. Bhabha cast his vote in favor of Vienna as the seat of the agency's headquarters because of his great love for opera or Western music, full stop. As a music lover myself, I have a special reason to be grateful to him. India has been a member of Board of Governors since IAEA has been established. This is just IAEA outside. Who's who in atomic energy, their busts are kept, and here is Bhabha's bust here. He was considered as one of the leading lights of atomic energy in those times. So I just want to also show what kind of person as human being Bhabha is. And Lal Bahadur Shastri died in Tashkent on January 11, 1966 while attending some meeting. So he wrote a letter to Srimati Lalita Shastri on January 23rd, 1966. Please note the date, January 23rd, 1966, because this is very, very highly significant. In the letter to Mrs. Shastri, he wrote, of course he expresses condolences. The staff of the Department of Atomic Energy, the Atomic Energy Establishment at Trombay, and Tata Institute of Fundamental Research decided to treat Saturday, the 22nd, which was a holiday for this organization, as a full working day in a fitting tribute to his history, his glory. Right? I mean, here is a man. I mean, we all fight to get a holiday or declare and whatever. Here is a man who is declaring our organization to be working on a Saturday as a tribute to this great man. That is Bhabha's work ethics. right? And sadly, he wrote this letter on January 23rd, 1960s, January 3rd, 1966, and see what happens on January 24th, 1966, newspaper. Bhabha among 117 dead in air these things, and this happened on Air India plane which crashed at Mount Black area. So on the day after he wrote this letter, I mean on the day that he wrote this letter, January 3rd, he was flying to Vienna for a meeting at IAEA, and unfortunately this Air India plane has crashed, and unfortunately we lost him. So what was Bhabha's contributions? What is the evolution of DAE? Let's look at it from beginning. So we have Tata Institute of Fundamental Research which started in 40s. We have Atomic Energy, we have Indian Railways, Department of Atomic Energy, then we have got Uranium Corporation, Nuclear Fuel Complex. So 40s, 50s, 60s, 70s, 80s and 2000. And so many organizations have come up, and now if you look at it, we are now talking of Atmanirbhar Bharat, means self-reliant India, right? And if you look at the picture of the DAE, essentially our story of Atmanirbharta of DAE has started way back in 1947, right? I mean, even you should make it 1945, because that's when the TFR has started. So it's because we have been denied so many things from Western countries. Almost all things that are in India in nuclear energy, most of them are made lock, stock, barrel at home. So in sense, we have been forced to be self-reliant in nuclear energy, which we have been pursuing by all these organizations. So again, since there are a lot of students, I just want to run through. So what all we have in terms of DAE, because this is supposed to be DAE Iconic Week. So DAE, if you look at various institutions, first and foremost is we got Atomic Energy Regulatory Board, which looks after all the nuclear reactors. Then we got about 6 R&D units. This is called AMD, Atomic Minerals Division Hyderabad, which looks at uranium mining. Then BARC, which looks at thermal reactors, advanced heavy water reactors. Then Indira Gandhi Center for Atomic Research, where I worked for a long time, works on fast reactors. Then you got something called Raja Ramanna Center for Atomic Research, which works on synchrotron lasers. Then you got VECC Kolkata, which works on cyclotron, medical cyclotron. This is a basic education unit. Apart from these two, you have a power sector called NPCL, which makes reactors for power production. Bharati Navika Vidyut Nigam Limited, which makes fast reactors. Then you also have a public sector, means they are not central government, they are public-private partnership, like under central government. You got ECIL, you got IREL, you got Uranium Corporation, and these are the industrial units, Heavy Water Board, Nuclear Fuel Complex, BRIT Mumbai, which makes isotopes and things like that. And of course, these are service organizations. Importantly, DAE also funds 13 aided institutes. Starts with Tata Institute of Fundamental Research, Institute of Mathematical Science, where we are sitting, and so on, so on. All these 13 aided institutes are fully funded by the DAE. Okay? So, and I also want to extend my hearty congratulations to Mathematical Science, since it is celebrating 60 years of its foundation, since its foundation. In fact, I happened to see this board today. It's so appealing that look at the title it has. I mean, this thing, the pursuit of science is at its best when it is part of way of life. That is, if you can pursue a scientific way of life, that's the best that you can do. So before I wind up, I just want to run through. People talk of 3-stage power program of Bhabha, and we all should know what is 3-stage power program. I'll briefly run through and we'll finish it. 10 minutes out. Is it okay? This 3-stage power program. So basically, if you notice, these are the various isotopes that we use, natural uranium, this thing. And when you got too much of fuel, you can go through and without reprocessing, and you take out the fuel that you use. However, in our case, what we do is we do the reprocessing and bring back the fuel, and AMD finds out the uranium, and UCAL goes and gets the uranium for you, and Heavy Water Board gets heavy water for you, and ECIL makes the electronics for you, and NFC makes the fuel rods and makes structural materials, and NPCL makes the reactors, and you have BRC, AGICAR and all supporting and things like that. This is a 3-stage power program of Bhabha proposed, and he said between thermal reactors to advanced heavy water reactors, you need to have fast reactors, because we got so much of thorium, and if you look at thorium that we have in the world, India happens to have 25% of the thorium. So if you can make thorium-based reactors, you will never be deficient of power. That was Bhabha's vision way back in 1950. And if you look at where thorium is there, it's all through the right part of the India. All through. Okay. So here is Bhabha. here is Sarabhai. There is so much of commonality between them. And Bhabha comes from affluent family and Sarabhai comes from affluent family. Both of them worked on costume craze. In fact, both of them have gone to Cambridge. While Bhabha has done his bachelor's and PhD with Fowler and Dirac, Sarabhai's the guide for doctorate or PhD was C.V. Raman himself, because he was doing his PhD sitting in IISc and then he went to Cambridge to complete his work. So Sarabhai had taken over from Bhabha after Bhabha's death. And look at what age they have died. Such an eminent scientist. Bhabha had lived only for 56 years and Sarabhai had lived only for 52 years. Right? However, their legacy that they leave behind is so large and so distinct that we can see. And there is a close correlation between space and atomic energy, because it's Sarabhai who was heading this space program when Bhabha was the chairman of this thing. So last but one point, I just want to talk of what Bhabha's scientific work. Right? All the students know when you become an author, you have to contribute to 4 aspects to be author of a paper. Author 1, author 2, and first author has a maximum contribution in terms of these things. So what has been Bhabha's publications? Look at Bhabha's publications. This is during Cambridge period Bhabha. It's all Bhabha single author. It's all Nature, Proceedings of Royal Society and Proceedings of Royal Society. And this is at IISc where he turned into experimentalist. You can see papers in collaboration with Chakrabarti, who was his student, and Corbin and things like that. This was during his Bangalore period. And this was after he became director of TFR and AET. He still has so much paper. Bhabha had 104 papers, of which Bhabha is single author in 79 papers. That talks of whether he was individual scientist, whether he was experimentalist, whether he was chairman of Atomic Energy Commission, or whether he was director of TFR. He was just a single man army. He never stopped his scientific research and he was prolific in his scientific paper. The administrative work never came in the way of his scientific research. So this is the last thing about Bhabha. So we've seen what is Bhabha as an institution, as an individual scientist. We saw Bhabha as an experimentalist. We saw Bhabha as an institution builder. And let's look at Bhabha as what is an artist. Okay, here is Bhabha's own portrait when he was 17. This is an oil painting by Bhabha himself. Bhabha is supposed to be very good at pencil sketches. These are pencil sketches drawn by Bhabha. This is also a canvas painting. This is C.V. Raman, pencil sketch by Bhabha. This is Niels Bohr, a pencil sketch by Bhabha. And you can see Bhabha with Cecil Powell, who discovered the so-called pi meson, Nobel laureate. And Powell thinks so high of Bhabha. And Powell is one of the fellows who thinks Bhabha's work is very monumental in cosmic ray. And Bhabha with the Niels Bohr in TFR. And here is Bhabha with C.V. Raman and so on. So these are all the awards Bhabha got. He was Fellow of Royal Society in 91. He was awarded Adams Prize by Cambridge, which is very decorated. Padma Bhushan, president of this conference, and he was honorary doctorate from so many universities. Here is Bhabha getting his doctorate degree, the Doctor of Science from Queen Elizabeth in 1960. After Bhabha died, the government of India has released a stamp in his honor. Look at what they have written on the stamp. Bhabha's stamp says, here is Bhabha, here is this painting brush and things like that, and here is this stanza from this musical this thing. Here is Reactor of Cyrus, a versatile genius. He had not only made an outstanding contribution which brought him worldwide recognition to research in the new and exciting field of nuclear physics, but he was also an accomplished artist and musician. Raman said him Leonardo da Vinci. And essentially this is what the stamp is talking of. Okay, and this is really sad. And at 25, Bhabha wrote a letter to one of his colleagues, December 1934, when he was 25. Look at what he wrote. Bhabha wrote, I know quite clearly what I want out of life. Life and my emotions are the only thing I am conscious of. I love consciousness of life and I want as much of it as I can get. But the span of one's life is limited. What comes after death no one knows, nor do I care. Since therefore I cannot increase the content of life by increasing its duration, I will increase it by increasing its intensity. Art, music, poetry and everything else that I do have this one purpose, increasing the intensity of my consciousness of life. And here is a man who is professing how the life should be spent. I mean, you don't have to live for a long time, but whatever you live, live fully. This is J.R.D. Tata, and he was a very good friend of Bhabha. He wrote, Homi was one of those who made me believe that some men in human history are born with a stamp of predestination on them, which leads them to accomplish beyond ordinary human capabilities. Some of them, Homi alas was one, are also predestined to die young, an unconscious premonition which drives them to superhuman efforts to complete their task in the shortest time allotted to them. Right? I mean, they know they have very short time, they have to accomplish so many things, and they finish and go back. He is a scientist, engineer, master builder and administrator, all stepped into humanities in art, music, and Homi was truly a complete man. In fact, whenever these Nobel laureates used to come, Bhabha used to make it a point to meet them, all the important persons. And here is our friend Niels Bohr meeting with J.R.D. Tata. He introduced me as Nobel laureate, my good friend. He introduced me to J.R.D. Tata. So I have come to the end of it. So what do you mean by science when we do all the research? It's basically curiosity, passion driven. And when you go to engineering, it's basically you try to make a prototypes and which is aim driven. And when you go to technology, you make products and you basically look at how it can be used in the society. So you go from basic science to engineering, from engineering to technology. It's like a cycle, right? One man who testifies all this is Homi Jehangir Bhabha, because he was not only a scientist, he was also an engineer and he was also a technologist. So Bhabha is a dedicated and perfectionist. Whether he did research, arts, music or institution building, he was full of energy and enthusiasm. All his intense efforts were directed towards nation building. What we need to do, by imbibing his qualities, we can create more Bhabhas and transform the country. That's all we need to do as individuals. And I end by this quotation where it says, by Buddha, we are what we think we are. All that we are arises with our thoughts. With our thoughts we make the world. But what you mean is, you think of what you are, you become what you want to become. Means, I think I am great, I become great. I want to build this great institution. You build the institution because your thought process, if it is strong enough, it drives all your energies towards it. Right? It sounds so unbelievable, right? One man who says all this is true is here, Bhabha. Right? He conceived, created, and served the nation in the form of atomic energy. Okay. So thank you. These are all the references I have taken from about all these things, and these are the 4 books I am referring to which I have used. And thank you.
Thank you, Amarendra, for a wonderful and inspiring talk. I wish we had even half an hour more to learn more facts about Bhabha. It was really truly inspiring. Thank you very much.
Thank you. Thank you.